Hello and welcome to today's session on the VEX IQ Generation 2 Brain. My name is Rob from STEAM Labs. In today's video, we are going to be having a look at how we can use the console window in VEX Code IQ browser version to actually set up and monitor sensor values from a robot using the inertial sensor, optical sensor, and also the distance sensor. Towards the end of this video, we're also going to be doing some deep calibration on the inertial sensor, which is built into the Generation 2 brain, and hopefully that will help you write reliable programs for the full volume season. Now, without further ado, let's get started and have a look at where to begin. Hello and welcome to the session on the VEX IQ Generation 2 brain. We are going to be exploring how to use the optical sensor, the built-in inertial sensor, and look at how to do deep calibration, and also explore the distance sensor in today's video. Now, as mentioned at the beginning of the video, I am going to be using codeiq.vex.com. I see so many students and coaches still using the standard software which was released by VEX many years ago. It is much more useful to use codeiq.vex.com instead of using that traditional software. Now, there are going to be a couple of things that you have to do at the beginning in order to install the device drivers, but that will pretty much prompt you how to set these up and how to get your brain connected. Now, I've got my sensors already added inside my devices window. I've got bumper and also touch LED added in too, which are two of the Gen 1 sensors, which are still very useful. And we are going to begin by looking at how to use the console window. So what I want to be able to do is monitor the surroundings of my robot. Now, rather than me looking at the brain, I want to be able to get them to be displayed inside this console window over here. So inside my print block, I'm going to select the drop down option over here and change this from brain to console. I'm going to want to add in a second block again, and this one is going to be for our actual sensor. I'm going to go into sensing, and we're going to have a look at what is the optical sensor able to detect. So first of all, can it find an object within the room? We're going to give it a meaningful name here, and we're going to call it opt, and we're going to say find, using a short abbreviation here, just so I don't take up too much space inside this console window, because we want to be able to display multiple sensor values. The next thing I'm going to want to do here is grab a forever loop and put that in, connect it, and then download this code here. So we are trying to see, can the optical sensor find an object within the room? Now, when I press start, it's going to print this thousands of times. And we can see currently it's just printing it all the way across the screen, which is really annoying. What I want to do, from the looks option, we want to set the cursor to the next row. So rather than it printing sideways, let's get it to print down. So let's press on download again. Let's press on start, and let's ignore the power cycle prompt. And this time it's printing out thousands of times. Has it found an object? Put my hand in front of it, and it's going to change it to true. Now, I think for students, this is going to be quite confusing because these sensor values are being printed so many times per second. What we want to do is try to slow down what we are seeing inside the console window by adding in a wait block and setting up a delay of 0.5 seconds. Now that we've done that, before we press on run or start, we're going to select on clear. And now the information which is going to be printed out is much more manageable because it's being displayed at a slower rate. Now, what else can we get the optical sensor to do? I think I probably want to be able to see the different colors that it is seeing by looking at the color hue, and also monitoring the brightness of the sensor surroundings inside the room. I'm going to duplicate these blocks by right-clicking I'm going to delete set cursor to next row and that time delay. And I want to add in a little bit of spacing here because we want to be able to display things pretty much going across the screen in a column. So I added in 5 spaces. Gonna put these 2 blocks in between, and we now want to try to monitor the color hue. So what range of values is it able to see? If we download this code again, if we clear what was previously inside our console window, what we'll now be able to see is multiple things being displayed. It's saying, can it find an object, and what is the color hue value? But I think we probably want to change this text here rather than it being found to be hue. Let's press on download again. And then we're sending multiple pieces of data back to our computer from our brain. So let's clear this. We've got color hue, and we have also got, can the optical sensor find an object? So we've got kind of a range of values being displayed. Now, last thing which I'm going to show you here is what is the brightness level in the room. So we're going to duplicate this code once more. Get rid of the last 2 rows. We're going to leave that spacing in just so it's nice and clear seeing the differences between the sensor options of can it find an object, color hue, and then this time we're adding in brightness. So we're going to switch out that optical block. We're going to change the meaning of our print statement, and we're going to say BGT colon, and then now if we download this code to the VEX Code IQ Brain, we're going to be able to monitor multiple things here. So console window again, let's press on start, and now we're able to monitor the brightness level inside the room. If we put an object in front of it, we can see that brightness level is changing from 0 to 2 and then other values. We can see the color hue. If I grab a white object, what do these values actually change to? So color hue is changing 0, 20, 336, 20, 20, 20. Brightness is 1. Optical hue is now 59, 329, and object found is also true. So this is the first demonstration of how to use console and how to actually use the optical sensor on the Gen 2 brain. Now, another option inside the sensing block window down here is we can turn a light on our color sensor to create artificial light within a room. We can adjust the amount of light which is being displayed on the optical sensor. We can turn up the brightness and decrease it. And we can also change it from color mode to gesture mode. So this is a particularly important option on the new optical Gen 2 sensor. Now, just what is gesture and what can we use it for? So if we select on the question mark symbol and select on the block, it explains here how we can use this gesture option here. So an example of how we could use it is it says, the example below waits until the optical sensor detects an up gesture before driving the robot forward. I think that's pretty cool. This has never been built into any of the other Gen 1 sensors before. I'm not going to demo this right now. I will leave you to explore this yourself, as well as the other options which you can see. Next thing we're going to have a look at is how do we use the distance sensor and what are the different values that the distance sensor is able to detect. Now, the new distance sensor is already added into my device's window. I no longer want to monitor the color brightness, so I'm going to take that out here. And what I want to do is find out what values can the distance sensor detect. Now, it's got up to a range of 2000 millimeters. So it's going to be 200 centimeters or 2 meters. I think that's probably larger than the actual IQ field itself. So that's going to allow you to see how close the robot is to an object, or how close it is to a wall. We're going to put that into this console block up here. We're going to add it back into our program, and we're going to say here distance colon, and then I'm going to point my sensor at a wall, and we're going to see what kind of values is the sensor able to set and how reliable is this sensor. So let's clear what's in this window over here. Let me find the distance sensor, and if we press on run up here or start, we'll be able to see that if default my distance sensor is pointing at my ceiling, I'm turning it around to point at my room now, and it's picking up another object. If I point it closer to the wall, the distance sensor is around 78 millimeters from the wall. Move it further back, and we're seeing value 126, 159, 156. And now I think this would be a good time to add in an if statement. So what I want to do here is I want to set up a question for the program which we have under when started here. We want to say something like, if the distance sensor is less than 200 millimeters from the wall, so that's 20 centimeters, we want it to stop the program from running in its entirety. So we're going to add in a maths block. We're going to select on less than. We're going to go into sensing. We are going to look at distance in mm, and we're going to say if it is less than 200 millimeters, we want the program to end. And we're going to probably want to display something on the print console window. We are going to say sensor value less than 200 millimeters. Okay, so now that I have done this, after this we are going to add in that break option, and then our program should end and stop running. Now, just to make sure to begin with that the distance sensor is seeing something which is greater than 200 mm, I'm going to hold it up. I'm going to press on download. We are going to go over to our console window. Let's see if this fails and see if I need to pause the video. Download, and then we are going to start. So distance value is 9999 to begin with because it couldn't pick anything up. It's currently pointing at my ceiling. If I now point it at my wall, what happens to the program? And we can see that the program is no longer running and that it has ended. Now, why did it not print this out? So the program ended, but actually what I wanted to see was this print statement here. We've got print sensor value is less than 200 mm, and we want to display this on the console. Now, what I'm going to do in here is I'm just going to add in this set cursor to next row. I suspect that it's printed out that information somewhere on the right hand side, and we just can't see that. We're also going to add in a wait block, so before the program uses the break block and it ends, we're just going to add in a delay of 1 second. We are going to run our program again. I'm going to hold up that distance sensor so it's not pointing at the desk. We are going to download the program. We are going to go to console and clear. Press on start. And distance sensor is around 130 centimeters from my ceiling. Point it at the wall. And now the program has ended. So we've seen sensor value is less than 200 millimeters and the program stopped. Okay, so we have used the distance sensor to look at how we can get it to detect how far the robot is away from an object. But what else can it do? So there is other functionality for the distance sensor. We can look at, can it find an object, just like optical, but we can also have a look at the object size that the sensor is seeing. Now, I've written a program here which is using if, elif, and an else statement here. And what we want to be able to do is we want to be able to see what would the sensor consider to be a small, medium, and a large object. If we think about this theoretically, the further away the object is from your eyes, the smaller it's going to be. As it moves closer, that object is going to get bigger. And the distance sensor works in the same way. Now, rather than you chasing your robot around the field, we can mimic what the robot should do with print statements and output this in console. What I'm going to do is press on start, and my distance sensor is looking at the ceiling. So around 1300 millimeters away, it's considering that that object size is small. I'm going to pick up this orange object here, and I'm going to place it in front of the distance sensor. At around 242, 246, it's considering that this object is of a medium size, which means that something is closer to the sensor. And now if I put it right in front of the sensor, at around 60 mil and even closer, this is considering that the robot is large, which means that the robot should be closer to the object that it is trying to detect. Now, hopefully that makes sense, and you can use both small, medium, and large sensing for object detection in the full volume game. We're now going to move on to how to do deep calibration on the inertial sensor. Okay, so deep calibration with the VEX IQ Gen 2 brain. So this isn't something which I see many people doing, and when I was speaking at an educators conference recently for VEX IQ and VEX V5, this is something that most people had no idea about. So I think it's really important to note that you do have to calibrate your sensors in order to get them to function properly. Many students are not always using sensors, they're just trying to get the robot to drive forwards for 200 and then right 90, and they get really frustrated when their programs don't work as they would expect. Now, the first thing to note here is the orientation of your brain. So you can see mine is currently flat. Now, before you go to an autonomous match, you should consider the orientation of your brain and if you have actually selected on the calibration option. The guidance is you should place this brain up against a wall or up against a book in order to calibrate it properly. I'm going to change the view of my GoPro, and hopefully you'll be able to see at the moment that the values on this brain, they're currently changing, and the heading is currently set at 359. If I place my brain up like this, these values are going to change again, and they're going to continue fluctuating even when the brain is up against a wall. And this is going to cause your autonomous programs to malfunction. So the way to get around all of this is just put the brain down like this, hold it up against a wall or a book, and just select on calibrate. This is going to reset all of those values to 0, and then you're going to be able to see that my heading is set at 0, and the values, although they're still fluctuating a little bit, they have actually improved. Now, if you are writing autonomous programs and you've been through that calibration procedure, which I just demonstrated, and if your brain is still not working as expected, or if your robot is still not behaving as expected, we've got something which is called deep calibration. In order to do this, you hold down these buttons on the left-hand side, both together, for a period of around 5 seconds. This is a more advanced way to reset your inertial sensor. It's saying, do you want to start calibration? The option is yes. It's asking us to wait. Do you want to set 360 degrees? Yes, we do. Do you want to confirm that we want to save this? We're going to select on yes again. And this is going to perform that deep calibration of your sensor. And we can see that heading is set to 0 now. Now, what I would recommend is if you are going to be going to autonomous matches, if you want to be sure that your sensor is behaving as expected, we can see that it's always slightly off. Do perform this calibration and deep calibration procedure, and hopefully you will end up with more accurate autonomous programs.